Last lesson of chapter 7 is going to be quite a bit easier than the other three, I think. It's complete review from grade 11 until the very last example. It also gives us a little more variety in terms of whether we use radians or degrees. So for the people that are struggling with radians, this one we kind of get to go back and forth and use a little bit more degrees. In fact, almost all the examples today are going to be in degrees, which makes it a little bit easier. Okay, so this is what the note looks like for you guys. It's just 2 pages back and front, solving linear trig equations, a couple examples on the back. I'm going to just highlight some of the examples, and then for the rest of them, you can obviously just take a look yourself and figure them out. There's quite a bit of repetition here. There are 8 full examples filled out, so there's no need for me to sit here and do all of them with you. Okay, so the main idea here is you're going to see a bunch of trig equations. Remember, the word equation means it has an equal sign. So sometimes it'll be in terms of x, other times it'll be in terms of theta. They kind of flip back and forth. And the idea is you're going to see some sort of equation, like any of these 4, and you're going to have to solve for x. Okay? And we learned about solving equations starting in grade 9. And it's really no different with trig equations. You're just going to have to implement all the skills you already have. So you're going to have to use the cast rule, you're going to have to use the quadrant numbers, you're going to have to use related acute angles. But it's all very familiar to you because you did it in grade 11 and we did it again last unit and a little bit this unit. So if I asked you to find all the values of x for which sine x equals 1, the easiest way to think of it is just think about what the sine graph looks like. So the sine graph is a repetitive periodic function that has a crest and a trough, a crest and a trough, crest and trough, and goes infinitely in the positive x direction and infinitely in the negative x direction. What I'm asking you is, when does this graph equal 1? So when is the y value 1? So I just put the dots here for the part that I've drawn. Remember, it's infinite. For the part that I've drawn, I see that sine of x is equivalent to 1 at pi over 2, which is 90 degrees, at 5 pi over 2, 450 degrees, and at negative 3 pi over 2, negative 270 degrees. And what I'm saying here, etc., means infinite. If I keep going in this pattern, you'll see more and more values of where sine of x equals 1. In fact, they keep increasing by 2 pi. Why do they increase by 2 pi? Because the period of sine or cosine function is exactly 2 pi radians, or 360 degrees. So if I keep adding 360 degrees, I'll keep finding all the values that equal 1. If I keep subtracting 360 degrees, I'll find the ones on the left side of the axis that equal 1. Okay, so the fancy way to write this is sine of x is equal to 1 at pi by 2 plus 2 pi times n. N being an integer. Now remember, integers are any whole numbers, positive or negative. So I could throw in a 3 here. So it'd be pi over 2 plus 6 pi. Okay, just means 3 more cycles down. Okay, I could throw in a negative 5 here. Pi over 2 minus 10 pi. Okay, 5 cycles the other way. Okay, so that would be the fancy way of writing what that equaled. Okay, so that's the first thing, just to get an idea of it. Now we start to say, well, do you want to have infinite answers? Well, we know they exist, but for our liking, we're going to stop the answers, or just kind of restrict the domain so that we only look between 0 and 2 pi. If we were only looking between 0 and 2 pi here, we would only have one answer, okay, instead of infinite. And that's what we're going to do for the rest of them. For this course, always restrict the domain between 0 and 360, which is the same as saying 0 and 2 pi. Okay, that's either one cycle when you look at it in terms of sine or cosine, or it's going to be one revolution around the axis when you're looking at in terms of radial arms. Okay, so the first 3 examples I want to do are complete review. Basic examples from grade 11 is what I've called them. Okay, so in all of these ones, it's going to look the same. So if you're in my class, they'll look very similar. We look at the sign only to tell us what quadrant it's in. Okay, so if you set this up using a little cast rule here, okay, you want to say, where is cosine negative? Well, we know cosine is positive here, where the C is, and where the A is, right? Remember, A stands for all. Okay, so this is quadrant 1, 2, 3, 4. So it's positive in 1 and 4, which means it must be negative in quadrant 2 and quadrant 3. That's all I want to use the negative sign for, just to tell me where cosine exists in this sort of axis. So I now know it exists in quadrant 2 and quadrant 3. I now need to find what is my related acute angle to that. So remember, we used an alpha to represent related acute angle. And to find alpha, we just solve this. We just do cos inverse of 1 over root 2. Okay, now that's a special triangle, but you can also just use your calculator in degree mode or in radian mode and find that this is equivalent to 45 degrees, which we are now familiar with in terms of radians, which is pi over 4. So both of those answers are acceptable. That's the radian measure, okay, and that's the degree measure. And that's what a related acute angle is. Well, what does that mean, related acute angle? Well, I want to find out what is my x, or what is my theta, what's my original angle starting at the stationary arm. Remember, we go counterclockwise. So in order for me to find x or find theta, I have to look at this angle in the 2 quadrants that I know it's in. So I know this is in quadrant 2, so that's 45 degrees, or quadrant 3, and that's 45 degrees. What we have to do is say, well, if that is 45 degrees, that's your related acute angle, what is this? And this is the x we're looking for, this angle and that angle. Okay, so you have to use the idea that all the way across is 180. I subtract 45, I get 135. Okay, in terms of, where did I write this down? In terms of what that means in radians, that's 3 pi by 4. Okay, because remember, if it's pi by 4, all the way over here would be to pi, which is 4 pi by 4. I subtract pi by 4, I'm at 3 pi by 4. The other one, the other acceptable answer is to go all the way around. So you go all the way to pi and you add another pi by 4. So that's 5 pi by 4. I'm going to do that answer second. And then the angle would be, in degrees, 180 plus 45, 225. Okay, so those are the 2 possible answers you would get where cosine of x equals exactly negative 1 over root 2. So if you're looking at the graph here, you're only looking at this little chunk, and it equals negative 1 over root 2 in 2 different spots, which sort of makes sense in terms of what's going on here. Because you're going to 2 pi, negative 1 over root 2 is somewhere down here, and it hits there, and it hits there. You know, it's going to hit in multiple areas. Now that's the sine curve, but you get my idea. In all of these questions, as long as we're just looking at x here, as long as our period is 2 pi, we will always have 2 answers. Okay, it's going to change if there's a number in front of the x, and I'm going to spend some time doing that example. But for anyone that the x is beside the trig ratio, so it's either cos x, tan x, sine x, or they're... I'm filming.
Okay, we just need to get something. We're making a fort.
Oh, okay. Let me help you get in.
We just need that the blanket.
What blanket?
We're making a fort.
This blanket, the big one?
Yeah.
Okay.
That one. Because we need the big blanket and the other big blanket.
Okay.
So we made a mistake. We already used the big blanket. So we need another big blanket. And this is the biggest one we could think of. Oh
Okay.
yeah, we're in the house.
That one, there's another one like that on top of Morgan's bed.
Yeah, but that one she's sleeping with.
Oh, you're keeping it for the nighttime?
Yeah, of course.
Okay. Don't make anything crash, please.
Well,
Okay. Goodbye. Okay. Sorry about that. Okay, so for all of these, we're going to get 2 different answers. So, again, we're going to follow the exact same rules we already had. If you see the sign out front, that only determines which quadrants it's in. So you keep sort of using the cast rule. Maybe I'll draw something. Well, it doesn't really matter. I have the cast rule here. So if I'm looking for where is tangent negative, tangent's positive in 1 and 3. So tangent's negative in 2 and 4. I then don't need that negative symbol. I then go ahead and I find my related acute angle. by doing the inverse of whatever this happens to be. Now this one's not a special triangle, so this one you'll do in degree mode on your calculator. It'll make your life much easier to do them all in degrees. 0.1944, and it's in my calculator's in radian mode, of course. Second function tan is 11 degrees. Okay, so your only goal is I need to draw that 11 degrees in quadrant 2 and quadrant 4. So this is 11 degrees, and this is 11 degrees. Remember, your angle is always with respect to the x-axis, the idea that you're dropping a perpendicular. So what we're looking for is, remember, this is the stationary arm, always on the positive x-axis. What is that angle? And what is this angle all the way to here? Okay, those are the x's we have. And we're going to get two different answers always. So the first one, not quite 180, subtract 11, 169. The second one, not quite 360, subtract 11, 349. Okay, it should all look sort of familiar in terms of review. Okay, one extra step with this one is if it's a secondary trig ratio, you have to convert it back to the primary equivalent. So cosecant is a reciprocal of sine. And remember, the term reciprocal just means to put 1 over it. So I'm just changing this from cosecant x, which equals negative 1.7, to sine x equals negative 1 over that. Now again, I look at this negative only to tell me what quadrant it's in. Look over the cast rule. Sine is positive in 1 and 2. So here we're looking at 3 and 4. We no longer need that negative. Find the related acute angle. You'll do sine inverse of 1 over 1.7013. Again, just get your calculator, make sure it's in degree mode. Second function sine, 1 divided by 1.7013. And I get 36 degrees. And then it's just a matter of drawing them in the two quadrants I learned they were in. One's in quadrant 3, one's in quadrant 4. And again, the real goal is for us to say, okay, here's the stationary arm. I want to find x, which is there, x, which is there. So this is 180 plus 36, 216. This is 360 minus 36, 333, 24. Okay, so for all of these, you'll start noticing a pattern. They all get two answers. They all show up in two of the quadrants when we're going between. Remember, this starts at 0 degrees, goes to pi by 2, goes to pi, goes to 3 pi by 2, goes to 2 pi. This is between 0 and 2 pi, 0 and 360. Okay, so just be aware, we're sticking with the restrictions that we had in place. All of these look similar. There's no number in front of the x. They all have a natural period of 2 pi. Doesn't matter what it is. Okay, so those should all be reviewed. This whole page should look very familiar to stuff that we did in grade 11. Now, if you look at the note, what I've done is I've addressed the first situation here. I've gone down and I've done the first example that they have. Okay, they did it. I have it in degrees and in radians like they do. Then on the back, I've picked a couple off. I did number 3 and I did number 4. Okay, so I didn't do 1 and 2 because it's too much the same as this one. So I just skipped ahead to those. I'm now going to look at 5, 6, and 7. 5 and 6 I'm not going to solve. I'm just going to start. And 7 I'm going to work out all the way through. So bear with me while I erase my one board. I want one that flips around, or multiple boards. I simply used stuff I had in my house. So for Christmas, my daughter got teaching supplies because she wants to be a teacher. So all these whiteboard markers are hers. Stole them. I left her whiteboard in her room, but this whiteboard I had in my shop that I used to list projects I was doing. Okay, let's go back. Okay, so what they had here for examples. Example 5 looked like this. Root 2 sine theta minus 1 equals 0. Now, the only key to this is you have to rearrange it. So some people look at these questions. Obviously, in this one, you're trying to solve for theta instead of x. So what you want to do is just bring everything to the other side that isn't the trig function. So if I bring, I'll leave the root 2 here for a minute. If I bring the negative 1 to the other side, it becomes positive. Then to get rid of this root 2, I have to divide both sides by root 2. So I now have this scenario. Now, once you have that scenario, you answer them exactly how we answered the other 3. Okay, you look at this and say, well, where is sine positive? So-and-so quadrants. Find the related acute angle, find the 2 angles. Okay, example 6, very similar. It's set up 3 cos x equals cos x plus 1. The only difference in this one is now cos x appears twice, so it appears like it might be a little more tricky. But it's not. Just like in grade 9, bring all the x's to one side, bring all the numbers to the other side. You're still going to solve this in the same manner. 3 cos x, bring the other cos x over, it becomes negative. So 3 cos x minus 1 cos x is 2 cos x. That equals 1. Divide both sides by 2. Cos x equals 1/2. And again, once you have that, you just go ahead and solve. Okay, same idea. You look at this and say, where's cosine positive? Find the 2 quadrants, find the related acute angle and solve. Okay, what I really want to do is example 7. And somewhere for the 6 people that are still watching, put a star beside this one, you're going to see it again. Okay, very similar to this. Sine 3x equals 0.5. That's what this one looks like. The thing is we want to look at all values between 0 and 360 degrees. Okay? Now, the issue with this one, and the one thing that's different about this one than the other ones, is this 3 sitting right here. Okay, that's unlike everything else we looked at before. There was no number in front of the angle. It was just a 1, essentially. Sine theta, cos x, tan x, secant x, whatever it happened to be. Now there's a number in front of here. And remember what this means. That's a b value. Normally sine x has a period of 2 pi. Well, this one has been horizontally compressed by 1/3. So the period of this function is now 2 pi over 3. Okay, in terms of putting that into degrees, is 120 degrees. So we're actually getting, in what we want, we're actually getting 3 cycles of the sine graph. Okay, because we want to find all the angles up to 360. Well, normally, how many answers have we got for every question? Only 2. But now we're seeing 3 cycles appear, which means we're not going to get 2 answers. We're going to get 2 times the 3 cycles, 6 answers. So we know because of this, we will have 6 solutions. Okay, so I'm just writing that on the side there just to remind myself that I'm going to have to use this period of 120 degrees once I kind of get to the end. Okay, it's common practice to make your life a little easier to pick another value. Because this is in terms of x, we might as well pick theta. To equal 3x, so you can just write this as sine of theta equals 1/2, 0.5, whatever you want to write. Okay, so we've replaced the 3x with theta just to make this a question as easy as that. Now you're going to go about this and solve it. This is really the only part that we have to, that's a little bit tricky. You're going to go about this and solve it the exact same way we did before. Here's the cast rule. Here's the quadrant numbers. This is positive. Where can sine be positive? In the all quadrant and in the sine quadrant. So I know it's in quadrant 1 or quadrant 2. I can find my related acute angle alpha by doing sine inverse of 0.5. Okay, so I do sine inverse of 0.5 and I find my related acute angle to be 30 degrees. Now this question specifically is allowing you to do it in degree mode. So if it's allowing you to do it in degree mode, go ahead. If you had to convert this to radians, you would just multiply by pi over 180 and you'd get pi over 6 as the angle if you wanted to. Okay, so I've now found it's 30 degrees is my related acute angle. I look at this, here's 30 degrees in quadrant 1. Here's 30 degrees in quadrant 2. Remember that you're starting always from the stationary arm, so when you go backwards you get, okay, what we've called theta in this case is going to be 30 degrees, or we have to go all the way to here, If we got to this axis, it'd be 180 degrees, back up 30, it's 150. Okay, so we get the two answers for theta, okay? But what you have to remember is theta was equivalent to 3x. So if I go backwards now, I say, okay, theta is 30 or 150. That means 3x is 30 or 150. Well, how do I get the x by itself? I have to divide everything by 3, right? Divide by 3, divide by 3, divide by 3. And I get answers here, that cancels, of x equals 10 degrees and x equals 50 degrees. Okay. This is the scenario. If you left it like that, you would get almost all the marks except for the end mark. What you have to be aware of is if the answers are 10 degrees and 50 degrees, but we need to look all the way from 0 to 360, don't you think there's going to be some repetition? Think about what the graph looks like. Up and down, up and down, up and down. How many cycles are we getting within 360 degrees? If one cycle is 120, the first cycle takes up 120. The second cycle takes you to 240. The third cycle takes you to 360. We have 3 cycles, which means we need to get 2 more sets of answers to this set. How do we know how much to increase by? We look here. If the period is 120, that means every 120 degrees, you're going to have a repetition in the cycle. So what we need to do here is add 120 degrees to these up until we get to something less than 360. We can't go past 360. So if I add 120 degrees to this, I know that at 10 degrees, if I add 1 cycle, I'm going to be back where I wanted to. That's 130. If I add 120 to this, I'm going to be up to 170. Keep going, add 120 again. So it might be easier if I kind of show it this way. Add 120, we get 130, right? Add 120, we get 170. Then add 120 again, we get to 250. Add 120 again, we get to 290. Now, if you weren't sure you had 6 solutions and wanted to keep adding, you'd add again. If I add 120 to this, I get 370. We're only allowed to go to 360. Okay, so this allows us to get the 6 solutions we are looking at, and all because our period is only 120, but we need to state answers for the domain up to 360. So again, if you were going to look at what this graph looked like, that really answers the whole question for you. If you look at this graph, so it's a sine graph. Oops. I didn't give myself enough room there. This is 360 degrees here because we're saying one cycle takes 120. Second cycle gets you to 240. And they're saying, where does this equal 0.5? There, 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 there. Okay, 10 degrees, 50 degrees, 130, 170, 250, 290. It all starts to make sense when you look at the graph. Okay, so just be cautious of that number popping up. People that don't watch the video will have no idea what that means. They're not going to know how to solve for that. People will start dividing by 3. Anyway, they're going to make mistakes. So maybe star this, maybe take a screenshot of this. Just be aware that when the assignment comes out, I'm very tempted to put a question like that. Not 100% sure, but tempted to put a question like this one just to make sure people are still paying attention. 6 of you, I think. Okay. All right, that's the end of chapter 7. Chapter 8, when we get there, we're going to start it really on June 4th. We're going to shrink it down to 8 lessons. It's not as tricky as Trig 2, I would say. It's going to go quite a bit faster. And then we're done. Like, we're looking here, right now it's Monday morning, so we're looking at just over 2 weeks to get finished grade 12 courses. If you are in grade 11, you'll have a little bit longer, but if you're in grade 12 courses, they will end abruptly. Okay,